Alright, so chemistry. Let us look at atoms, molecules, and ions. Under this, we are going to look at fundamental chemical laws. That's my main interest, fundamental chemical laws. Now, in chemistry, we have three major chemical laws. And the first one is called the law of conservation of mass by Lavoisier. So the first one is called the law of conservation of mass, which was made by Lavoisier. Alright, what does this state? This states that this states that mass is neither created nor destroyed in a chemical reaction. If I've got A and B are reacting to form C, the mass of A, and B will not be distorted just because they are forming C. Law number 2, it's the law of definite proportion. Definite proportions, which was proposed by Proust. This states that a given compound always contains exactly the same proportion of elements by mass. This is what. So a given compound always contains exact the same mass same proportion of elements by mass. It's supposed to be a given compound here. So let's say this is compound A, B, let's say 2. This compound, it has got elements in it, okay, that are combined by a certain proportion, but this is defined by their mass. So exactly the same proportion of elements by mass. A here is 1, B here, let's say, is 2. So even the mass of this one is 1 to 2 to the mass of this one. That's what we mean. The last law is the law of multiple proportions, which was proposed by Dalton. It's the law of multiple proportion, which was proposed by Dalton. This states that when two elements form a series of compounds, let's say compound element A and element B, they form a lot of compounds. What happens is that the ratios of their masses, the ratio of their masses of the second element that combined with 1 gram of the first element can always be reduced to a small numbers. So when two elements form a series of compounds, the ratios of the second element that combines with 1 gram of the first element can always be reduced to small numbers. Guys, let A and B be what? Be elements. These can form a series of compounds. For example, they can form AB as a compound, they can form AB2 as a compound, they can form that depending on the valence. Now, the second element will combine with the first element. Now, the first element has been given a mass of 1 gram. So the ratio of the second element that combines 1 gram of the first element can always be expressed as what? As 1 number. It's simple as that. Okay, so just a quick one. Let's look at the Daltons theory. The Daltons theory. The Daltons theory. Theory. Now, we've talked about Dalton theory, like Dalton, especially on the law of multiple proportions. Now, Dalton's theory was actually achieved in the year 1808, just doing. And it has the following postulates. The following are the postulates of the Dalton's theory. It says each element is made up of tiny particles called atoms. So each element is made up of tiny particles called atoms. It further says the atoms of a given element are identical. Okay? That means the atoms of the different elements are also different in some fundamental ways always. So the atoms of a given element are what? Are identical. Identical. That means even atoms of different elements are also what? Are different in some ways. This was Dalton. He further says chemical compounds are formed when atoms of different elements combine with each other. So compounds are formed when atoms of different elements combine. He further says chemical atoms do not change. Atoms do not change. Do not change in a chemical reaction. In a chemical reaction. Okay, so these were some of the postulates of Dalton's atomic theory. It also has to do with the chemical reactions involving the reorganization of the atoms, and it also changes in the way they bound each other. So a chemical reaction just does not distort atoms. No, it only rearranges them, reorganizes them in a certain way in order to fit that particular path. Thank you.